Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. In the previous video, we saw that IV can eliminate attenuation bias by finding a valid instrument, which unfortunately is extremely difficult. So before turning to IV, researchers usually ask a simpler question, which is, can we improve the data itself? Prevention is better than cure in this case. So the cleanest solution to measurement error is to not have it in the first place. Okay, so that means that the better solution, which would be better data, the most direct fix is to collect more accurate measurements, which means better questionnaire design, better survey methodology, better measuring equipment, and better administrative records. Okay. So instead of asking people, for instance, to recall their income, which introduces rounding, misremembering, and deliberate misreporting, use official tax records. The data are more accurate, the measurement error is smaller, and the attenuation gets reduced. This is also why the shift toward administrative data in economic over the last 20 years has been so important. So linked employer-employee data sets, tax registers, school administrative records, all have dramatically lower measurement error than survey responses. Another way would be also to do repeated measurements. So suppose we want to measure the same variable multiple times. Instead of asking, how many hours did you study this week? Just once, ask it 4 times across the semester and maybe take the averages instead. Under classical measurement error, errors are random. So some responses might be too high, some too low, but averaging multiple measurements causes the random errors to cancel out. So the average would probably be a more accurate measure than the true value that you are, like the true value than any single response that you get. Now, this works specifically because classical measurement error has mean zero. So systematic errors, non-classical measurement error, don't cancel with repetition. It's just averaging 4 bias responses that gives you the same bias. You could do validation samples. Which means suppose that for a subset of survey respondents, we also have an accurate measure, self-reported income and tax record income. Researchers can use this validation sample to quantify how much measurement error exists, estimate the reliability ratio, or adjust the OLS estimate by dividing by the reliability ratio or the attenuation factor, as we called it, to recover the true effect. Now, this correction only works if the validation sample is representative of the full sample. If the people for whom you have accurate data are systematically different, then the correction may introduce its own bias. You can use administrative data, which means that you would take tax returns, school records, hospital records, employment records, so actual hours work, actual health measures, actual grades, and so on. Now, administrative records are compiled for operational purposes, not for research. So they would typically have much lower measurement error than self-reported surveys, but at the same time might not be as available across like the different types of data. Keep in mind, sometimes administrative data only covers certain variables and certain populations due to the target and the reason why they are built. So it might be difficult to get a hold of them or to get a hold of what you need at the same time. You could look into better instruments and technology, but sometimes the solution simply isn't statistical, is technological. So you could get better pollution sensors, better GPS tracking, better wearable devices, electronic transaction records, and so on. Now, this is increasingly relevant in economics because you've got the explosion of digital trace data and also data brokers in there, from your use of smartphones, payment systems, and online platforms. They provide new high accuracy measures of variables that previously might have only been available through surveys, but clearly they would be also the most expensive to get your hands on. Ultimately, the idea is that unfortunately there's no perfect solution. There is a trade-off, so there's strengths and limitations to all of these solutions that we are talking about here. This table offers a little bit of a summary of the strengths and the solutions. So with better data, you're definitely removing the problem, but it's often expensive. With repeated measurements, you're reducing the random error, but you don't eliminate systematic error. With validation samples, you can quantify the error, but it does require additional data. Administrative records, often very accurate, but may not be available. And ultimately, we saw IV, which corrects endogeneities, but that means it might be difficult because it requires a valid ID. So the right approach depends on what data and instruments are available to you. One of the most important lessons in econometrics is that statistical methods cannot fully compensate for poor quality data. Okay. You can apply the most sophisticated estimator in the literature to SLS, GMM, LIML, but if your data are badly measured, your estimates will still be wrong. So good econometrics starts long before the regression is run. It starts with careful data collection, thoughtful survey design, honest assessment of where measurement error might exist. So this is a lesson that gets neglected in methods courses, including this one, because we spend most of our time on what we do after the data arrive. But the best applied economists are as careful about data quality as they are about identification strategy. The best solution to measurement error is prevention, so better data, repeated measurements, or administrative records, with IV as a powerful but demanding alternative when accurate measurements are unavailable. And with this, we've now completed the measurement error arc. We understand the problem, the consequences, and the solutions. In the next video, we'll bring this to life in R, simulating measurement error and observing attenuation bias directly. So stay tuned, and I'll see you then.